Good morning, girls. So today we are working on questions 13 and 15. I'm doing the correction from the last day. So this is on page 218. I've given you classwork on Wednesday to do questions 13 and 15, and I'll correct it now. We'll be then moving on to a new topic, and it's called statistics, and it's called presenting data in statistics. So statistics has two chapters, as you'll see when you go to the index. And on the index, chapter 12 is statistics, but we're going to leave that one for the moment. And we'll do a little bit more interesting. It's called presenting data, chapter 16. So we'll be moving on to that next. Okay, so in question 13, you're asked to find a total length of ribbon used to tie a box as illustrated, and 15 centimetres extra is required for the knot to tie the bow. Now, in class on Wednesday, one of you had asked how you actually calculate the bow. Well, think about it. You need bow that goes the perimeter of the shape in one direction and the perimeter of the shape in the opposite direction. Once you have that and have your answer and got the total, you'll add 15 to it to get what is actually required. So I'm just going to draw out the box. So this is page 218, and I am doing questions 13 and 15, and I'm starting off with question 13. And I'm just going to draw that box. Okay, and I'm in a different colour. I'm going to talk about the bow. So the bow is going to go all the way around in one direction. So the red bow. And then there's a bow that's going to go across the long direction all the way around. And on the underside and on the far side. Okay, so they're the two pieces or perimeters that I need to get the total. And I'm going to add 15 to it. So I'm just going to use the measurements that are on the actual book. So I'm going to talk about the red perimeter first. And the red perimeter, as you can see, it's 10 centimeters tall, plus it's 15 centimeters wide. Then it's going down the other side again, the same height of 10, and it's going to cross the bottom again, 15. And you're going to add up those. And you can just grab your calculator for this. It's 50 anyways, but sure, look, we'll do it on the calculator so you can see 10 plus 15 plus 10 plus 15. And that's 50. So that's 50 centimeters in one direction. So the red perimeter is 50. We now need to calculate the purple perimeter. And I'm only using colours just so you can see what I'm talking about. You don't need to do that. So you can just call it direction 1 and direction 2. So again, it has to go 10 up, 20 across, 10 down, and 20 on the underside. So that's 10 plus 20 plus 10 plus 20. And some of you might have this calculated in your head, but you'll be getting 60 centimeters. But we'll do it on the calculator so you can see. 10 plus 20 plus 10 plus 20, which is 60 centimeters, as I was saying. Now, there's extra needed. And it said it wanted 15 centimeters extra. And I suppose that's to tie the bow on top, because if it was just the right length, you'd just be able to reach around the outside. I'd say the extra bit is so you can tie a bow on it. Okay, so we're just going to add up those totals. 50 plus, I don't know if you can see that there now, 50 plus 60 plus 15 is 125 centimeters. Okay, and that's the question done. So it's very practical. You'll be wrapping presents hopefully next Christmas or even for birthdays, and you can be able to calculate how much ribbon you'd need in order to actually wrap the present in all directions. Okay, so next we're going to talk about question 15. And I'm just going to show you question 15 first before I start. So question 15 is very typical of a few questions that I've given you so far. You're asked to get the volume and the surface area of the box. And I am just going to redraw out that shape, and then I can work on the different components with you. So in redrawing it out, question 15. So there's a small side, and then the base is a little bit bigger, and we've a couple of sides built onto that. And then obviously it's a closed box because it has the same width again. So there's 6 sides onto this. I'm going to use the measurements from the question: 4.3, 2.1 and 3.5. The volume is an easy one. It's the length by the width by the height. And we're asked to correct it to 1 decimal place, and this is part 1 of the question. The length of it is the longest bit, so it's 4.3 by. The width of it is how wide it is, which is 3.5. And the 2.1 is how tall it is. So I multiply by 2.1. So on your calculator, 4.3 by 3.5 by 2.1. And we're getting 31.605, and it's asking me to correct it to 1 decimal place. Now, in correcting it to 1 decimal place, you don't have to consider all 3 spaces. You just look at 2 spaces. And for 2 spaces, it's 60. The nearest number is 6, not 7. Okay, if you were correcting to 2 decimal places, it would change the number to 61. But 1 decimal place is just 0.6, and that is volume, which is meters cubed. Grand. Next part, part 2. And I'm just going to label this color coded like I did the last time. So this is the bottom, and the bottom has 2 pieces that are exact same size. Okay. Then we have the front, and there's 2 pieces the exact same size. And then there are the sides, and there's 2 pieces the exact same size. So in doing surface area, you need to get the area of all of those shapes. And as you can see, there's 3: the bottom, the front, and the side. And to get the area of the bottom, it's length by width, obviously, but it's 4.3 by the width of it, which is 3.5. And guess what? There are 2 of them. So you'll multiply your answer by 2. So it's 4.3 by 3.5 by 2, which is 30.1. I know my writing is going to get a little bit small here now, but it's okay. 30.1. Next one, the front and the back, which are the exact same size. That's 2.1 by 3.5. And again, there's 2 of them. On to the calculator. That's 14.7. And the last one, the side, is a 4.3 by 2.1 rectangle. And again, there's 2 of them. And by 2, which is 18.06. Great. Now that we have the area of all of the 6 sides, because I did 2 of them, I did 2 of them, and I did 2 of them, we're just going to add all of those up together. So it's the 30.1 and the 14.7 and the 18.06, and that is 62.86 meters squared. Now we are asked in the question to correct it to 1 decimal place, and we look at the 86 and we think, okay, is it closest to 8 or 9? Is it closest to 80 or 90? And because it's gone more than halfway, you will round up. So that's 62.9 meters squared. Okay, and that completes the classwork that you were doing on Wednesday. We are now moving on to a brand new chapter. Okay, so your title for this is obviously chapter 16, because that's what we're moving on to. And it's called Presenting Data. And as the title suggests, you're going to present. That means you're going to do it with graphs and diagrams to present information. So go to page 352. Okay, your title is Presenting Data. We're going to do something very simple today. I'm going to just introduce the keywords. I'm going to do an example, and then I'm going to get you guys in class then to do a few questions for me, and we'll leave it there then for this week. So, as I was saying, presenting data, you will, at the end of this chapter, you'll be able to interpret line plots. And I'm going to explain what line plots are in a minute. I'm going to explain what bar charts are next week, and stem and leaf plots. And hopefully by the end of the next week or 2, that we'll have done all the different types of ways of presenting data. Okay, and we'll be able to read tables. That's basically what you need to be able to do by the end of this chapter. So an example of a line plot. And a line plot is one of the easiest ways to present information. 25 pupils in a class were asked to write down the numbers of children in their families. Okay, so you're given the table of results below. So the number of children, there might have been 1 child or 2 children or 3 children or 4 or 5 or 6 different children. This number of families that had 1 child, there was 4 families that had 1 child. 6 families had 2 children. 7 families had 3, 5 families had 4, 2 families had 5, and there was only 1 family that had 6 children in it. Okay, and that would be typical enough. There'd be few enough families that would have more than that at the moment. So we will now show this information on a line plot. On the horizontal line, so those of you that don't do graphics, horizontal is a line going straight across, vertical is a line going up. So on the horizontal line, we write the number of children per family. So these are the small numbers, 1, 2, 3, 4, 5, 6. And each child is represented by a dot as shown. So I'm just going to redraw this out for you. So I'm going to rewrite out the table very fast. So the table is number of children. And then this is the number of families. Okay, and you get your ruler for this, obviously, but obviously I'm doing this a little bit faster just to get it explained to you. So 1 child had 4 families, 2 children had 6 families that had 2 children, there was 7 families that had 3 children, there was 5 families that had 4 children, there was 2 families that had 5 children, and there was 1 family that had 6 children. Okay, and that is the basic table. So you will be faced with a similar kind of a question, and you might be asked to do a line plot. So you give it a title, line plot of number of children per family. And very simply, as the line plot suggests, you draw a line. And underneath the line, you give the different numbers of children per family. And it's really important that you give equal spacing for this. So I'm going to just pick a place to start. And I'm going to say 1. And then maybe every 2 boxes or every 3 boxes, I'm going to give the next number. So 2, 3, 4, 5, 6. Notice that I've kept an equal space, 3 boxes, 3 boxes, 3 boxes, 3 boxes, 3 boxes. If you're using a normal copy and you don't have squared pages, just pick a regular measurement, like every 2 centimeters. That'll keep it nice and even for you. Okay, so for 1 child, there are 4 families. You just do dots. 1, 2, 3, 4. Notice that I'm using the squares of my copy to make these nice and even. So that's 4 families. Number of family that had 2 children was 6. 1, 2, 3, 4, 5, 6. 7 families had 3. 1, 2, 3, 4, 5, 6, and 7. There was 5 families that had 4. 1, 2, 3, 4, 5. There was 2 families that had 5 in it, and then there was 1 family that had 6 in it. Okay, so very easily, reading from the table, you can see straight away, okay, there's 4 that have 1 child. There are 6 that have 2, 7 that have 3, 5 that have 4, 2 that have 5, and 1 that has 6. And it's been able to read a table. Sometimes you might be asked a question on it, like how many families have 3 children in it, and then you just count up 1, 2, 3, 4, 5, 6, 7. You'd be able to give the answer of 7. So that's what a line plot is. You draw a line and you're presenting the data that you're given from a question. Sometimes you might be asked questions on it. In class now, you're going to go to, and I'm just going to move up this a second, page 353. And you're going to do questions 1 to 4. Okay, some of these you'll get done really, really fast because you don't have to draw the line plot. Others you might have to draw the line plot. But you can start now and join me live. Thank you.